well, let's get to know. All right, so today we're going to learn one equation. The only equation we're going to talk about today is when you see the phrase uninhibited growth or uninhibited decay, we're going to use this formula right here. All you need to know is what each letter means. So whatever is out front, the A sub t is your population after time. Whatever you start with is your A sub 0, and it's always written first. Then we have a button in the calculator. K is going to be your growth rate or decay. If it's a positive number, it's growth. If it's a negative number, it's decay. And T is time. So all we're going to do is practice plugging in. It's super easy. Are you ready? All right, so first example. So example 1 says, a colony of bacteria grows according to the law of uninhibited growth. So we're going to underline that. The minute you see that on the test, it tells you to go to this formula. So you have to know that this is the formula that I need. According to the function, n sub t equals 100 times e raised to the 0.045 t, where n is measured in grams and t is measured in days. The first question they are asking me is to determine the initial amount of bacteria. Just a second ago, we said the initial amount is in the A sub 0 spot. So what is in the A sub 0 spot? 100. So we have 100 grams of bacteria. And I don't know what bacteria we're dealing with here, but we've got 100 grams of whatever it is. The second question they ask me is, what is the growth rate? Well, growth rate is wherever K is. So if I look up here, what's in the K spot? And how would I write that as a percent? Yeah, 4.5. Move it 2 to the right. So the first couple of questions is just asking you to identify. Questions on those? All right, go ahead and cross out C. We're not going to graph it in our calculator. D wants me to actually use the formula. It says, what is the population after 5 days? So they want to know, what is A after 5 days? So what did we start with again? What's my A sub 0? 100 times E raised to the 0.045, and then times how many days? 5. Okay, now we're just going to go to our calculator. Nothing magic here. We're just going to type it in. 100. Second ln to make the E pop up. 0.045 times 5. So we have 125.23 grams after 5 days. So that's just a plug and chug. There's nothing hard, as long as you know where the little K is and where the T is and where the A sub 0 is. Do you feel comfortable with that? Part E is actually going to require a little bit of work. So on part E, they want to know how long it will take. If they're asking for something about how long it will take, they're asking me to find the T. Anytime they ask you to find the T, they should give me everything else. So where do you think this 140 goes? Yeah, it goes near A is. So we have 140 equals 100 e to the 0.045, and I'm solving for T. Now we did this last week, but you might have forgotten. I'm trying to get this T up here. That means it's an exponential equation. When you have exponentials, I want to get like bases. Can I get a like base here? No. So we're going to have to use another approach. Do you remember what to do when you can't get like bases? You're going to log or ln both sides. Very good. Before I take the ln of both sides, what do I need to do with this 100 so that E is by itself? Divide. And I'm not even going to touch the calculator yet. I'm just going to write it down. So this side's going to cancel. And I have 140 over 100 equals e to the 0.045t. And now we're going to do exactly what Kaylee said. We're going to ln both sides. So ln of 140 over 100 equals, when I ln the right, what happens to the 0.045? Comes down out front. So 0.045t ln of E. Now what happens to an ln of E? They cancel because it's like 1. And 1 times all this is just all this. So 0.045 times t, so how do I make that just a t? I have 0.045. So here we go, calculate time. So I'm going to go type in ln. I'm going to type in 140 divided by 100. Notice that it opened parentheses. So what do I still have to do? Close them. And then I'm going to hit divided by 0.045. So how many days is it going to take to have 140? 7.48. All right, and so we've had a lot of discussion about rounding or not. If we're talking about bacteria, and we're talking about growth of bacteria, it's probably important not to round, because what if there's a certain level of bacteria that becomes something that makes it bad, spoils it, or makes it deadly? Do you want to round that and then round incorrectly and someone gets sick? No. So I'm going to leave 2 places after the decimal on most problems for that reason. Okay? All right, last one on this page. It wants to know what is the doubling time. So I'm looking for t again. And this time they're asking me about doubling. Doubling what? Doubling the original.
The bacteria.
Yeah, the original. And how much did I have originally? 100. So if I double it, I have a 200. So we want to know, when am I going to get to 200? So 200 equals 100 e to the 0.045 t. It's the exact same type of problem, except now I have a 200 over here. So I'm going to follow the exact same steps. What did we do first on the problem we just did? We divided by 100, and I said we're going to let our calculator do it. I'm not even going to mess with it. Then what did we do to bring the 0.045 out? We LN'd it. So that ln is going to make the 0.045 come out front, and ln of e is just what? 1. So what do I have to do to this ln of 200 over 100? Yep, divide it by 0.045. Alright, so calculate time. So we have the ln of 200 divided by 100, and I know that y'all know that that's 2 in your head. I just want you to practice typing it all in. Close the parentheses, divided by 0.045, and I got 15.40 days. Did y'all get the same thing? So is it hard? No, this is not a hard day. This is actually pretty easy. Questions for me on example 1? All right, let's go look at example 2 then. So on example 2, it says, the population of a certain bacteria, there's my thing again, obeys the laws of uninhibited growth. So as soon as I see that, I know I need this equation the day of the test. If there are 5,000 cells initially, and there are 128,180 cells after 8 hours, they want to know what is the population size after 10 hours, and they also want to know how long until the population count is 1 million. So I have to do 2 things. What did they not give me in this problem that I need in order to do it? They didn't give me the rate. Did they give me 2 population sizes though? Okay, so if I have 2 population sizes, and I know the amount of time it took for that to occur, I can go find my rate. So we're going to go plug in. So this 128,180 goes first. That's my population after some time went by. And it's going to equal what we started with, which was 5,000. E, do I know the K? No. Do I know the time? How many hours did it take? Yep, so it's 8K. And we're going to go solve for K. Is K in the exact same spot that T was?
Yeah.
So is it the same process?
Yeah.
That's why today's so easy. So I'm going to divide by 5,000, same process. And then we're going to LN both sides again, nothing different than earlier. ln of E is still 1. And I'm going to divide all this by 8. K is a percent, so I want 4 numbers after the decimal. So when we type this one in, we want to put 4 numbers after the decimal. So ln of 128,180 divided by 5,000. Make sure you close those parentheses and then divide it by 8. So 0.405, I'm going to round up 5. Have I answered a question yet? We haven't answered the question yet. I need this to answer the question. So on your test that y'all are going to have, not this week but next week, there are going to be a few problems where they don't give you K. You have to go find K so that you can answer the question. All right, so I'm going to draw a little line right here. And over here to this side, I'm going to write K. That's what we did first. We found K. Now I'm going to go over here and answer the question. They wanted to know what is the population after 10 hours. So the population after 10 hours, we started with 5,000. Going to have E. My K is now 0.4055 times, how many hours am I looking for? 10. We're just going to go type that straight in our calculator. 5,000 E raised to the 0.4055 times 10. Ooh, that's a big population. So 28, 84, 25.82. So 288,425.82. They didn't tell me what we were measuring it in. It just keeps talking about number of cells, so I'm just going to write cells. Tell me what questions you have. They're really quiet. More so than normal. All right, they asked me a second question. They want to know how long until the population count is 1,000,000. They want to know how long we're looking for time again. So how do you write 1,000,000? How many zeros do I need? 6, very good. So we're solving for t again. We've done this a couple times now, so I bet you can do this without me. Okay, go solve for t without me. Go. Divide, ln, and divide. Okay, how many hours will it take for me to get to 1,000,000? Perfect. 13.07 hours. Question. Chris, you okay? Just checking. Tracy, you good over there? Anybody need me to wait? All right, last one we have to do. So the only reason I'm doing this last problem is the vocabulary. By the way, I did a horrible job typing on your version, so let's find my typos. It should read the half-life, not like, of a radioactive potassium is 670 years. If 10 grams are present now, how much will be present in 100 years, and then also in 1,000 years? What do I have to go find again before I can do anything to the problem? You gotta go find K. That means they have to give me 2 population sizes. They give you 2 population sizes, but they do it tricky. What did we start with? 10, and they told me the half what? So what would be half of 10? 5. So your other population is 5. So it's 5 equals 10 E. I'm looking for K. So how long did it take me to get to the half-life? What is my T? 670. And I'm going to go solve for K. So again, we're going to divide and ln both sides. And then you're going to divide by the 670. And I want K Alright, so a lot of people don't like to say this one out loud because they feel like they did it wrong. So we've got 5 divided by 10, the ln of 5 divided by 10, divided by 670. You are supposed to get a negative. Why? Because it's decaying. Very good. To get negative 0.0010. You have to put the last 0? No, you don't. You can if you want, since I said do 4, but that's the same thing whether I put a 0 there or not, right? Okay, so let's go answer their questions. They're actually pretty easy questions. They just want to know how much. So they just want the population. So this is just a plug and chug. So the population is going to be what we started with, which was 10 grams, times E. My rate is negative 0.001, and they want me to do it for 100 years. Let's go type that in your calculator. Wow, only after 10 years, it was at, I'm sorry, right, it only went down, gosh, barely any after 10 years. So is it decaying fast or slow? Really slow, because remember our growth rate is 0.001. So it takes a long time for this radioactive potassium to leave, doesn't it? Okay, let's go figure out where it is at 1,000, because that was the second question. So exact same process. Except instead of 100, I'm going to put 1,000. So how can you make your life easy right here? Just hit second, enter. It pops back up. Go arrow to the 1 to the left. Type in an extra 0. It's still not all completely gone after 1,000 years. I still have traces of it. 3.68 grams. Okay, this is why I said you should be able to finish your homework in class. Does this take long? Alright, so let's talk about what our homework is. Look at the second sheet of paper that you picked up. So on the homework tonight, on number 1, go draw a line through 1C. We're not going to graph it. On number 3, go draw a line through part B. We're not going to graph it. And then you can get rid of number 11 completely. I've left you with 5 problems to do and 30 minutes to do them. Is this something you can do right now? So instead of putting your head down, instead of taking a nap, I want everybody to get this done and turn it in before the bell so that we don't have to have late work. On your mark, get set, be productive.